All right, this is the review for Unit 7, Secondary 3. You will be testing next time we see each other. So since I wasn't in class, I wanted to go through this, and if there were any questions that you couldn't answer, I can do it for you right now, and you can look them up and see how to do them. So the first set of questions asks you to determine if the sequence is arithmetic, and if it is, find the common difference, the 50-second term, and the explicit formula. So to decide if it's arithmetic, you just need to see if it's increasing at a constant rate. So between the 18 and the -2, it's going down 20. Between -2 and 22, it's down 20, down 20. So yes, it is going to be arithmetic. Your common difference is -20. In order to find the 50-second term, I'm going to need to write the explicit formula. So the explicit formula says a sub n equals the difference times n plus the term right before the first term. So if there was a term right in front of this, what would it be? Well, if I'm going down 20, then that would have to be 38, so that there would be a -20 right there. If I wanted to find the 50-second term, you're going to plug that in. And grab a calculator. Whatever you get there. -20 times 52 plus 38 is -1002. If I wanted to write the recursive definition, that says a sub n equals a sub n minus 1. The recursive definition always starts out like that. When you're writing these, make sure your n and your n minus 1 looks like subscripts. It should not look like a multiplier. And then what's the common difference? I'm going down by 20, so -20. Every piece of this is part of the answer. Looking at number 2, from -25 to -32, it's down 7, down 7, down 7. So yes, it's arithmetic. D equals -7. A sub n equals -7n because of the difference times n. If there were a term right before this, -25 plus 7, it would be -18. If I want to find the 50-second term, let's just plug in 52. And we get a -382. So a sub n equals a sub n minus 1, and then the common difference -7. Number 3, looking at these from here to here, 193 minus -7 is 200. So is it going up 200 every time? Plus 200 plus 200, yes. So yes, D equals 200, A sub n equals 200n, and then what number would be right before this? It would be -207. -7 minus 200. A sub n equals a sub n minus 1 plus 200, because the common difference is 200. If I want to find the 50-second term, 200 times 52 minus 207 is big, 10,193. Last one in this section, I'm going down by 9 here, by 9 here, by 9 here. Yes, it would be D equals -9. A sub n equals -9n. And what would be there? Plus 32. A sub 52 is what? -9 times 52 plus 32. negative 436. A sub n equals a sub n minus 1 minus 9. So those are those problems. The next section asks you to determine if the sequence is geometric. So if it's geometric, it's going to be having a common multiplier or a common ratio. So we need to find the common ratio, the explicit formula, the recursive formula, and the three terms of this sequence after the last one given. So this one right here, I'm not multiplying by anything to get the next term, I'm just subtracting. So this is not geometric. This would be arithmetic, and we could do all of the things that we would have to do with the arithmetic ones, but we weren't asked to, so we're not going to. This one, to get from the 4 to the 12, it's a multiply 3. This also is a multiply 3. You can check it. This is also a multiply 3. So, yes, it's geometric. R equals 3. A sub n equals, the formula for this one is the first term, a sub 1, times r to the n minus 1. So, if I wanted to find the next three terms, I wouldn't actually have to plug anything in. All I have to do is take the 108, times that by 3, and you get 324, 972, 2916. The last thing we have to do is write the recursive formula, and that's going to be it. All right, from here to here, it looks like it's a multiply negative 6. From here, it's multiply negative 6, and it probably is there as well. Yeah. So, yes, geometric. R equals negative 6. A sub n equals your first term times your ratio to the n minus 1. A sub 52, oh, just kidding, we don't have to do that with these ones. The recursive, a sub n equals a sub n minus 1 times a negative 6. And the next three terms, negative 2592, 15,552, negative 93,312. Okay, last one. And to get this, it's a times 6. To get that, it's a times 6 times 6. Yep. Yes, r equals 6. A sub n equals the first term times your rate to the n minus 1. A sub n equals a sub n minus 1 times 6. So you've got your explicit, your recursive. And to find the next three terms, let's take that 864, times it by 6. 5184 times 6, 31,104. 186, 624. Cool. The next two questions, given two terms in the geometric sequence, find the common ratio and the eighth term. So these are big indicators. What would you do if they're geometric? Because you would do something different if it was arithmetic. What I probably do, first term, second term, third term, fourth, fifth, sixth. Well, we need to be able to figure out what r is. And we don't know the first term. So the formula with this one is the first term times your ratio to the n minus 1. Well, we don't have the first term. So here's what I would do. Let's take those two. I'm going to start off by dividing them. So negative 972 divided by 36 is a negative 27. That means, change colors really quick. That means something times something times something equals a negative 27. So r cubed equals a negative 27. When we write it that way, we're used to cubes. It's really easy to see that r is negative 3. And if I wanted to find the 8th term, I can take that negative 972 times it by a negative 3 times by a negative 3. We do that twice because this is the 6th term. So the 8th term would be negative 8,748. I'll show my work right here. So if you check my answer key in class, you can see it. Let's do another one of those. This one's a little bit easier because we're told the 4th and the 5th term. So if I wanted to find my ratio, I'm just going to take 2592 and divide it by negative 432. So my ratio is negative 6. If I wanted to find the 6th, 7th, 8th term, the formula for the sum of a geometric series is the sum equals a sub 1, your first term, times 1 minus r to the n, all over 1 minus r. So for this, we need to know r, we need to know n, and we need to know the first term. Let's figure all of those out. A sub 1 is negative 1. It looks like I'm timesing by 4. And there's 9 terms. So you just have to plug everything in. It's all shown there for you. The first term times 1 minus 4 to the 9th, all over 1 minus r. If I plug the top into the calculator, I get a really big number. Divide that by a negative 3, because 1 minus 4 is negative 3. Still a big number. We expect these to be a lot bigger because it's geometric. When you add up things that are increasing fast, you're going to get a big number. Let's do the next one. I know the first term. The r looks like it's negative 2. I know how many terms there are. So s equals the first term times 1 minus r to the n, all over 1 minus r. I can't cancel those negatives yet because I have to apply this power 6 first. So plugging that into your calculator, 1 minus a negative 2, make sure that negative 2 is in parentheses. You get negative 63. Divided by 3 equals negative 21. R equals negative 4. S equals the first term times 1 minus r to the 9th power divided by 1 minus negative 4. Plug that in. Again, make sure that -4 is in parentheses. Doesn't matter quite as much this time because the exponent is a 9. But it's a good habit anyway. Sorry, I can't even see that. There you go. Last one. R equals 6. So S equals 2 times 1 minus 6 to the 7th power. It's going to be a big number. Over 1 minus R. 2 times 1 minus 6 to the 7th power. And I'm just going to divide that by a -5 right now, so I don't have to write down two extreme numbers. Number 27, you drop a ball from a staircase that is 36 feet high. By the time you get down the staircase to measure the height of the bounce, the ball has bounced 4 times and has a height of 2.25 feet after its 4th bounce. So, ball drops. Anytime you have a story problem, it's good to draw a picture the best you can. That's not the best picture, but at least you have a guide, a reference. So, a 36-foot high staircase. Pretty tall. That's not considered the first bounce. This one is, I would say. So, it's bounced once, twice, 3, 4 times. And this 4th bounce is 2.25. How high did the ball bounce after it first hit the floor? So we're wondering how tall that bounce is right there. What's the second term? So I would do these very similar to how I was doing these up here. Let's find the common ratio by dividing that out. This one was a whole number because 8 divided by 2 is 4. This one's going to be a decimal because 2.25 divided by 36 is going to be less than 1. So from here to here, 2.25 divided by 36 is 0.0625. And then how many bounces did it take to get there? So I'm sitting here at 4. 1, 2, 3, 4. If I take the 4th root, on your calculator, how you do a 4th root is 0.0625 raised to the 1/4 power is the 4th root, 0.5. So R equals 1/2. Which means if we want to know how high did the ball bounce after it first hit the floor, if it starts at 36 and it loses half of its bounce each time, the first bounce would be 18. It's really tall. Number 28. Write a geometric sequence of at least 4 terms with a positive common ratio. So if I'm doing this one, it just has to have a starting spot. Pick whatever number you want. It has to have a positive common ratio. It doesn't matter what it is. It just has to be positive and common. So if I said R equals 2, so 7, double it, double it, double it, and there's my 4th term. All right, the last are story problems. You're making an argument of cubes, or arrangement of cubes in concentric rings for a sculpture. The number of cubes in each ring follows the pattern below. Okay, so you have your sequence to be 1, 9, 17, 25, and so on. It doesn't really matter if you understand what a concentric ring is or really what's going on, because it tells you what the sequence is. You don't have to figure that out or draw the picture. So if I'm going from 1 to 9 to 17 to 25, it looks like I'm adding 8 every time. So for part 8, is it arithmetic? Yes, because my common difference equals 8. What are the next 3 terms? Well, 33 plus 8 is 41, 49, 57. If the sequence continues to the 100th term in this pattern, what will that term be? So in order to do that, you either need to add 8 a lot of times or come up with the equation. Again, from the beginning, the equation is the difference times n plus the first term, or the one before the first term, which if I subtracted 8, it would be minus 7. If I want to know the 100th term, 800 minus 7 would be 793. Number 30, each year a volunteer organization expects to add 5 more people to the number of shut-ins for whom the group provides home maintenance services. This year, the organization provides the service for 32 people. So 5 more than the year before. Write a recursive formula for the number of people the organization expects to serve each year. So any given year, I know that I'm going to take the previous year's number of people I serve and add 5. I'm increasing by a rate of 5 every year. The first 5 people in the sequence, 5 terms, I'm starting with 32. Next year I'll serve 37, then I'll serve 42, then 47, then 52, adding 5 every time. Writing the explicit formula, a sub n equals the difference plus the term before the first. If I were to subtract 5, I would get 27. How many people would the organization expect to serve on the 20th year? A sub 20 equals 5 times 20, which is 100, plus 27, 127. 31. When a pendulum swings freely, the length of its arc decreases geometrically. Find each missing arc length. The 20th arc is 20 inches. The 22nd arc is 18.5. So the one in between those two would be the geometric mean. So y equals the square root of 20 times 18.5. Part B, the 8th arc is 27 millimeters. The 10th arc is 3. So I'll do that out here. Again, geometric mean because they're almost consecutive. There's one missing in the middle. So y equals the square root of 27 times 3. Which gives you 9. And this part A was inches. Part C, the 5th arc is 25 centimeters. The 7th arc is 1. So y equals square root of 25 times 1 is 5. And the last one, 100th arc is 18. The 98th arc is 2. Times 2. It's the square root of 36. That would give you 6 feet. Cool. Number 32, the deer population in an area is increasing. This year the population was 1.025 times last year's population. Assuming that the population increases at the same rate for the next few years, write the explicit formula for the sequence. So a sub n, this is geometric or arithmetic. It's increasing by a percentage. This is the multiplier, so this is my r. So the formula is a sub 1, which is 20, it's a 2, 2537 times r, 1.025 to the n minus 1. That is off the side of the page, sorry. B, find the expected deer population for the 4th year. So a sub 4 equals the initial 2537 times 1.025 to the 3rd, because it's n minus 1. 2537 times 1.025 to the 3rd gives us 2732. I'm always going to round down. I'm talking about living things because we're not going to have a 0.07 of a deer. Deer's not running around with only the antlers, and it's not pregnant, so we're just going to call it 2732. 33. A bookshelf has 7 shelves of different widths. Each shelf is narrower than the shelf below it. The bottom 3 shelves are 36 inches, 31, and 26. The shelf widths decrease by the same amount from bottom to top. What's the width of the top bookshelf? Each shelf is narrower than the shelf below it. So it's going to look like a pyramid-ish. So 36, 31, 26. This is arithmetic because we're going down by 5 every time. From the bottom to top, going down 5. There's 7 shelves. What's the top shelf? So this is easy enough. This is the 7th shelf, the 6th, the 5th, the 4th, the 3rd, the 2nd, the 1st. This is my answer. If I were taking an ACT or the SAGE test and I didn't know how to do it, you would just have to problem solve. This is something where you should be able to draw a picture and figure it out. Now, if there were 100 shelves, maybe a different story, but 7 shelves, I can subtract 5 7 times. 34, an embroidery pattern calls for 5 stitches in the first row and for 3 more stitches in each successive row. So first row is 5, the next row is 8, then 11, and so on. The 25th row is the last row and has 77. That's nice. Find the total number of stitches in the pattern. So this is a series question, and it's an arithmetic series because I'm adding the same every time. So the arithmetic series is the same as the boy who had to be quiet and add the numbers from 1 to 100. Again, what did they do? They took however many there were in the series, how many digits of the series or terms of the series, divided it by 2, take the first term, add the last term, and you'll have your answer. Oh. $10.25. All right, 2 more and then we're done. Marching band formation consists of 6 rows. The first row has 9 musicians. The second row has 11. The third row has 13. And so on. How many musicians are in the last row? And how many musicians are there in all? So 6 rows. Again, if you wanted to add these together without actually using a formula, you can. How many musicians are in the last row? There's only 6 rows. So a sub 6 equals 19. And when I add them all up, the sum of my 6 rows is 54. Again, I would hope that you would be able to do that kind of problem before we even started the unit. Last one, 36. This month, your friend deposits $400 to save for a vacation. She plans to deposit 10% more each successive month for the next 11 months. How much will she have saved after the 12 deposits? So there's 12 deposits because you have 11 months and then your initial. This is geometric because of the 10% increase. The geometric formula is the first term times 1 minus your R. And this, because it's 10% more, R is going to be 1.1. The 0.1 is the 10%. The 1 in front means that I'm increasing. In order to find your growth factor, you take the growth rate, 10%, and add 1 to it. If you were losing 10%, maybe you made a bet and you lost 10% every month for whatever, or you had to pay a certain amount left on a credit card. If you were losing 10%, if it were decaying, you would subtract, so it would be 0.9. But we're growing, so we added. So R is 1.1 to the 12 deposits. All over 1 minus 1.1. I get, now I can round this to 2 decimal places because we're talking about money, not deers. All right, hopefully that was helpful. Good luck on the test next time. If you watched this, then awesome. Let me know. I was re-watching some of the videos re-recorded in class, and at some points the recording went funny and I sounded like a man who had a cold. So hopefully that didn't happen this time. There's a reason I never posted those on my website. Hopefully this was good for you, and good luck on the test. See you later.